Hey guys, welcome back everybody. So today we're going to talk about the EIGRP router ID election criteria and also the importance of the router ID in the EIGRP protocol. So as we know that the router ID is a unique on a per router basis, or we can also call it the per protocol domain basis as well, right? So let's example on a single router you're running the multiple routing protocol. So make sure that your router ID should be unique on a per domain basis, right? So the election criteria of the router is saying that first you have to give the manual preference, right? If you don't give the manual preference, then it will go with the highest loopback interface IP address. And if you don't have a loopback, then it will go with the physical interface IP address. And what happens if you don't have a physical interface IP address? Then in that case, the router ID will be 0.0.0.0, right? That's simply saying that the router doesn't have any router ID. Always in a production network, it's a recommendation to give the manual preference. I'll make a separate video on this one. Why do we require the manual preference on this one? Now understand the logic behind the router ID of the EIGRP protocol. So in EIGRP protocol, what happened? The router ID is used to prevent the loop, not only for the external route, even for the internal route as well. How? So let's say example, this is a topology right now we have. The router 1 is running with the router ID 101. Router 2 is running with the router ID 2.2.2. Router 3 is also running the router ID 1.1.1. Router 4 is running the router ID 4.4.4, and router 5 is running the router ID 5.5.5. Router 1, if you see, I have two loopbacks right now over here, and router 5 also have a one loopback over here, which is the 5.0/8 network. Now, what happened when the router 1 is going to send the update to the router number 2? Let's take example of the one submit right now, 1.0/8. It'll put the 1.0.0/8 network. And what R2 will do that? It's going to send this update to the R3. So when the R3 will receive this update, the 1.0/8 network, it's an internal route, right? What R3 will do that? R3 said, hey, this route is coming from the 1.1.1, which is the router ID of the R1, right? Same thing, what happened? My router 3 is also having the same route ID 1.1.1. In that case, what happened? R3 will see that, hey, this route is coming from my itself. So what he will do that, he will simply discard the update packet. So this is how we are preventing the loop for the internal route. Now let's say example, if I'm gonna advertise this route 11.0.0/8 as an external, it means that this was the internal route. Now, if I'm going to advertise this route as the external route 11.0.0/8, the route ID will be 1.1.1. And this is the external route right now. R2 will share this external route to the R3 as well. Same route 11.0.0/8. The route ID will be 1.1.1. In that case, also what happened when the router 3 will receive the own route ID in the update packet, they will simply discard this update as well. So this is how we are preventing the loop in the EIGRP protocol. This is the one of the most interesting scenario that you will encounter in the interview as well. Now let me show you this practical. So I already have a IP address configuration right now on every router. You can see that I did that before. So router 1 is 12.1 and the loop back over here right now. The same thing on the router number 2 as well. The 12.2 and 23.2 on the router number 2. The R3 can see the 23.3 and the 34.3 as well. This side. The R4, if you see 34.4 and 45.4. Remember one thing, these router doesn't have any loopback. This router doesn't have any loopback because these are my transit router, right? So I'm not putting any loopbacks on this router right now. The router 5, you can see that we have a IP address will be 45.5 and the loopback as well. Now what I can do that, I'll quickly configure the EIGRP. So on the router number 1, I'll configure the router EIGRP 1. Network, I'll say that 210.1.12.0 and that's all. I'll manually define the route ID. This is how you can manually define the route ID 1.1.1. And same thing, like what I can do that, I'll say that I'll say the network 1.0.0.0/8. That's all. On R2 now, router EIGRP number 1, EIGRP router ID will be 2.2.2.2, and the network I have a 2.0. And that's good. 23.0, and that's good. The EIGRP number 1 and EIGRP router ID will be 3.3.3.3.3. Network I have a 10.1.12.0, not 12.0. It should be the 23.0, and network I have 10.1.34.0. So I have this two network right now, 23 and 34. I advertise it. And same thing on R4 as well. I can use this command line as well. EIGRP router ID will be. So I define the manually preference right now and network 0.0.0.0. R5 as well, router EIGRP right now 1. And the network I have a EIGRP router ID will be 5555. One thing, remember that in EIGRP routing protocol, if you have a same router ID, even they will form the neighborship. So let's example, router 1, right, and router 2 right now we have, and they have a router ID 101.1 and router ID 2.1.1, this guy as well. They can still form the EIGRP neighborship. This is not going to happen in the case of post routing protocol, but in case of EIGRP, it form the neighborship. There is only reason is behind it, because in the hello packet of the EIGRP, we do not contains the router ID information. So if you do not contain the router ID information, I'm not going to share the RID information between the router. And that's why they will form the neighborship. But in case of OSPF routing protocol, what happened? Under the OSPF hello packet, we put the router ID. So that's why I can know what is my neighbor, and neighbor can know what is me as well, right? So that's why in the case of OSPF, they will not form the neighborship. But in case of EIGRP, they form the neighborship. That's good on the router 5. And I have a 45.2 as well. That's good. So on the router 1, I'll configure this guy. Here we go. And router 2 as well. Here we go. And router 3 as well. Here we go. So you can see on the R3 is done now. On R4, this is a basic mistake that engineers do in the production as well, right? And because of this router ID, duplicate router ID, you will see the bigger problem. The bigger problem is what? Your single autonomous system number right now, right? Your complete autonomous system is a single right now, AS number 1. We call as a process ID, right? It's gonna divide into the 2 sections right now. Why I'm saying that, so this is the AS number 1. So this part is totally divided right now. So this information, even the 1.0 information come to the R2. R2 will have this 1.0/8 information. R3 will not have, of course, because of the same router ID. Not even R4 will have, not even the R5 will have. So even my communication will be down from the R5 to R1 as. So you can see on the routers right now, router 1 is having the neighborship. That's good. R2 is also having the 2 neighborship right now, R2 and R3. R3, if you see that, I do have a neighborship with both the router, R3 and R4 and R2. R4, if you see that, I do have a neighborship with both them, and R5 also I have a neighborship right now. Interesting point, if you go to the R2, I do have a route for the 1.0/8 right now, but R3 will not have it. If you go to the R3 right now, R3 will not have the root show IP root EIGRP. They do not have it. Let's advertise this route as well. I forget to advertise it. So 5.2. That's my loop back. So let's check it now again. So R3 will have the, I did EIGRP route ID. Oh, by mistake, I configured the wrong ID. EIGRP route ID will be 111. Clear IP EIGRP. Case number 1, neighbors. That's all. Just give some time. Show IP root EIGRP now. Here we go. Come on. Yes. So you can see that, right? R3 is having the same router ID, and I'm having the 5.0/8 network because this guy's router ID 5.5.5. Mine is a 1, it's a different, so I can accept this route. But on the router 1, it's the same router ID, R3 and R1, it's not going to accept the route. So you can also see this thing in the events as well. So IP EIGRP events, they will show you the go on. And if you see, right, can you see that? So when R2 is sending the update to the R3, right, this update, it's an internal route, right? What R3 will do that? R3 will simply discarding it. Where's that? I'm ignoring this update right now because of the duplicate router ID. So R3 will just simply gonna drop it. So I'm not gonna accept this update right now. So this is how we are preventing the loop in the EIGRP protocol. This is for the internal route. Let's do the same thing for the external as well. So what I can do that on the router 1, I'll get the one route map, CCIE permit 10, match interface, loop back number 2, and I'm gonna advertise this guy connected dot map CCIE. I'm gonna capture this link as well. And here we go. So the loopback number two was the loopback number two is this IP address 11.11.11. So what I did that, I simply call this loopback instead of calling the ACL and prefixes, right? So this is another way that you can call it. And actually you can redistribute this route map. So now I can see that R2 is sending the update to the R3, right? 23.2 sending the update to the .10. And this is my external loop, which is 11.0/8 right now. You're going to expand it, this guy. And this is the external route type we have. And this is the external route destination and the submit mask information. They're already 1.1.1, right? So it's sending the update to the R3 right now. Same one, 11.0/8. And the route ID will be 1.1. This is the external route. And same thing will go to the R3 as well, 11.0/8 right now. The RID will be 1.1. This is also external route. What R3 will do that? It's simply discarded. So if you see on a R3 is not going to accept this route. So IP root EIGRP, I'm not expecting. Same thing if you see the so IP EIGRP events as well. You see the ignore dot the matrix is 11.0/8 because of the duplicate route ID. This is the external route right now we have. I'm just ignoring it. So this is how you can prevent the loop in EIGRP protocol based on the route ID. It's not only preventing the internal route, it's also do for the external as well. Thank you so much, guys. See you in the next video.